All right, welcome to our first lecture, uh, other than the introductory one I already did. So this first lecture, we're basically just going to do an introduction. This loosely covers, mirrors what is covered in your chapter one in your textbook. And I'll be talking about both these things. I'm going to separate this video into this lecture into several videos to make it easier for you guys to download everything. Okay, so let's start out with a definition of statistics. Statistics is the science of gathering, organizing, summarizing, interpreting, and presenting data. So data is just the plural of datum, and datum means a place of information, right? It can be anything. And we'll talk about how we turn information into something that can be analyzed or understood by computer programs. So in other words, statistics just means converting large amounts of information into something we can understand and use. So why might we want to do this? If we were in class, I'd elicit some answers here, but just to answer the question, it's used to summarize data we're interested in. And it also gives us a way to test theories and efficacies of treatments, measure people's attitudes, assess the relationship between traits, and so forth. It's also the backbone of a lot of things. Statistical models, they're behind, well, the ads that Google shows you when you search for something. Statistics is behind what Netflix suggests, the suggestions you get on Netflix or Amazon for future viewing or purchasing, right? Statistical models are behind the premiums, okay, the premiums that insurance companies decide to charge you and so forth. So statistics is really important. At this level, we're just going to worry about summarizing data and testing hypotheses at a most basic level, okay? So descriptive statistics refers to that first function, summarizing data. Inferential statistics is what we're talking about when we are testing theories and hypotheses, and we'll get to that in a minute. All right, so we are going to start with some definitions. We've seen the first, okay, statistical procedures and the answers obtained from these processes, those procedures, how statistics is defined, okay, in your textbook, I believe. Also, the science of designing studies, gathering data, and then classifying, summarizing, interpreting, and presenting these data to explain and support the decisions that are reached based upon it, okay? That's what we do as scientific researchers. In other words, as I said, converting large amounts of information into something we can understand in relation to a specific problem or area of study, right? Okay, so some basic terms. First, variable. This is any characteristic of a person or phenomenon that can take on a different value. Okay, it has to be able to vary. It can be your height, GPA, age, a personality, factors like openness to experience, morality, aggression, lots of different things. The important thing is that a variable has to take on different values. If it's all the same, then it's what we call a constant, any characteristic that cannot take on different values. So, for example, in students in my 5:30 on Tuesday class, okay, what class do you have at 5:30 on Tuesday? It's all the same. It does not change. If we have a sample of men and women, then we can have sex as a variable or gender, right? Because there's two values, men and women, and probably more, non-binary or whatever. But if we collect a sample and we're just looking at biological sex and our entire sample is male, then sex cannot be a variable. It will be a constant. It does not change. And that was the case for a lot of early studies in psychology. They only used men because they thought female hormones would mess things up, something that has recently been disproven. So moving on, data. Like I said, data is just pieces. Data is plural and a datum is a piece of information. So numbers or measurements collected as a result of observations. Okay. Remember, it's plural. Datum is singular. For example, when referring to results, we say these data rather than this data. The data show rather than the data shows. So for example, what year of school are you in? And you select which one, right? What is your GPA? What is your major? So this should be very familiar because by now you guys should have taken the day one stats survey that's available on Canvas. It links to a Google form, and we'll talk about that later as well. We will use that data later, and we will actually input that data into SPSS. So for example, how many psychology courses have you taken? Well, it could be 1, it could be 0, or now it's 1, right? Or 5, right? These are all examples of variables and data. Okay, those are the variables, and data are the answers that we get from those variables. Okay, so here we'd have year of school is a variable, and there are 5 different levels, right? And we'll get to that later. Okay. Statistical procedures are used to organize, summarize, communicate data, and conclude what the data indicate, right? Okay, so moving on. We're going to cover one more thing in this video. We're going to talk about, do a short math review. This is not a math course, right? If you read the homepage on Canvas, which I hope you did, I warn you that if you're taking this course to meet your math requirement, there are much easier courses to take. Probably pretty much any basic level math course is going to be easier than this course. The hard thing about this course is actually the logic and the plain English language, which means interpreting the results of statistical analyses in a way that anyone can understand, right? But even though it's not a math course, you do need some basic math. You need to know order of operations, parentheses, exponents, multiplication, division, addition, and subtraction, right? You need to know that X or Y, for example, they represent individual scores, okay? So addition, X plus Y, and so forth, right? For what might be new for you guys is this sigma, this uppercase Greek letter sigma, okay? This means add it all up. So let's walk through that, okay? So for example, if we have sigma x, that means we have to add up all values of x. 1 plus 2 plus 3 plus 4 plus 5 is 15. If we have sigma y, this means add up all the values of y. 3 plus 5 plus 7 plus 8 plus 12 equals 35. If we have sigma x times y, that means we have to first multiply, because remember, multiplication comes before addition in PEMDAS and order of operations. So we multiply 1, the value of x times the value of y, 1 times 3, plus 2 times 5, plus 3 times 7, and so forth, right? So 3 plus 10 plus 21 plus 32 plus 60 equals 126. So remember, order of operations, multiply first, then add. What if we have sigma x squared? All right, this means we have to square all the values of x, then add them up, because PEMDAS, parentheses, exponents comes before adding. So 1 squared plus 2 squared and so forth, it equals 55. All right. What about sigma x squared? So parentheses come before exponents, so we have to add them all up, right? Then square them. So 15 squared equals 225. Do whatever's inside parentheses first, and then the exponent. So a short review of exponents. X squared means x squared, so x with a 2 up there, or x times x. So 6 squared, 6 times 6 is 36. Radical x means the square root of x. So the square root of 36 is 6. Now, rounding is what gets people really messed up in this course. Okay, first, carry out all calculations so the final answer after rounding has 2 more decimal places than the original scores, right? The best thing is to keep all the decimal places. Decimal place just means everything that comes after the decimal, right? So 1.6 has 1 decimal place. 1.673 has 3. Default in this course, if there are no other instructions, you will round to 2 decimal places, unless it's a p-value, which we won't meet until around chapter 8 or 9, p-values are rounded to 3 decimal places. Okay, so 1.673 has to be rounded to 2. Because this 3 is less than 5, we just leave it at 1.67. If we had to round 1.676, we'd have to round up. So that would be 1.68. If you do not understand this, you need to review, all right? So importantly, do not round off at intermediate steps. Remember, hold all the decimal places possible into the very end, okay? Basic rules: if number in the next decimal place is 5, you round up the decimal place you're rounding to, right? If it's less, you just keep it the same or round down. Okay, there's a math quiz on Canvas that you should already have completed it. To move on to the next task in the module, you must complete this. If you did not get a perfect score, review. You can go to the Math Resources page and do it again. All right, okay, I'm going to stop this video and start another.